Hi everybody. Okay, we're going to do 5.3 now. I've moved to my washer and dryer. You're going to see my whole house. The dishwasher is just kind of glary with the lighting right now, so I thought we'd try this. And I can see the phone, but hopefully this works. So 5.3, this one is multiplying fractions, and this one's a lot easier. As far as it's pretty quick. The only problem again with the easy sections, like always, is it's so easy that we tend to kind of forget how to do it because it was just so easy, so it just kind of leaves us. So you just got to do a lot of them and practice, and maybe just memorize, study the different rules for the different situations with fractions. So again, so this one's going to be multiplying the fractions, and what we do when we have a fraction that needs to multiply by another fraction, or we're going to do some just whole numbers and mixed numbers as well. So we'll start off doing 3/4. Make sure I can see that good. 3/4 times 7/8. Okay, when you're multiplying fractions, you just multiply each number straight across. So you're multiplying the numerators with each other, and you're multiplying the denominators with each other. And that's all there is to it, really. So if you can multiply, you should be pretty good at this. Okay, so if I multiply 3 times 7, I get 21. And make sure you can see. And 4 times 8 is 32. Okay, we do need to reduce the fraction if it does reduce. If it doesn't, then you're done. But always remember to reduce your fractions. I can't say it enough. Reduce, reduce, reduce. On this one, the only thing that will go into 21 would be 3, 7, and 21. So if 3 or 7 or 21, I gotta see if you could see, 3 or 7 or 21 will go into 32, then we're good to go. But remember, those, whatever we divide into one, we have to divide into the other as well. So if it won't go into both of them, then we can't divide it out. It won't simplify. So for this one, as you can see, 3 will not go into 32, 7 will not go into 32, and 21 clearly won't go into 32 evenly. So it's already reduced, so we're done. So there's our answer. So it's that easy. Just multiply the numerator with the numerator, get your answer. Denominator with the denominator, and get your answer. Okay? We'll do another one and throw a negative in this time. If I have, say, 1/5 times a negative, gotta see where I'm at, negative 4/9. So same thing. You're just going to multiply straight across, but how does the negative play in? It's just like anytime we're multiplying numbers. If you've got a positive times a negative, you're going to get a negative. If we had a negative times a negative, we'd get a positive. Positive times positive is positive. But anytime there's only one negative and we're multiplying, that negative's going to carry through because he doesn't have somebody to make him happy, right? Okay, so now we multiply the top. So I looked at my signs, I got my negative, then I just multiply my numerators. 1 times 4, 4, and 5 times 9 is 45. Okay, then reduce, 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 right? If you can. Only thing that goes into 4 is 2 and 4. Well, I know 2 won't go into 45 because it's not even, and 4 will not go into 45 as well, evenly, so we are reduced. So negative 4/45. when we multiply straight across. Pretty simple. Okay? Let's try talking about a few different other unique situations or different ways it might look. One thing we need to talk about real quick, we haven't talked about, is what do you do when you have a negative on a fraction, and what does that mean? Sometimes the negative will be in line with the divide sign. That one's not quite in line. Let me fix that. So sometimes it will be kind of in line with the divide sign. Sometimes it will be in the numerator. Sometimes it will look closer, like that. Sometimes it will be in the denominator. This is the same as this, which is also the same as this. Let me make sure you can see all of those. So whether it's level, down below, or up top, it doesn't matter. It's all the same. It's all talking about a negative 1/6, the negative 1/6, the negative 1/6. Reason being is because what it's saying we're doing. Remember, the negative just hangs out, and we do 1 divided by 6. Here, I'm dividing a positive by a negative, which means I will get a negative, and I'm doing 1 divided by 6. Same thing here. I'm doing a negative divided by a positive, which will give me a negative, and I'm doing 1 divided by 6. So all of those are talking about the exact same number. Okay, so you'll see it written like this, or like this, or like this. You treat it the same no matter what. So the last problem we did, we had a negative and I wrote it out to the side. I'll do one now where I write it in different places. So we're going to do 1/4 with a negative 4. So 1 over negative 4. And I'm going to times that by a negative 1 over positive 5. Okay. Couple ways to look at it. You could do positive 1 times negative 1 equals negative 1. Negative 4 times positive 5 equals negative 20. And then the negatives, you'll have one upstairs and one downstairs and they cancel. Or the way I usually look at it is an overall picture. So I've got a negative number here because I've got a positive divided by a negative, so that's going to give me a negative. And same thing here, I know this one's negative, so I'm doing a negative times a negative, which means I'm going to get a positive. So I already know I'm getting a positive, so I just don't even look at the signs. And then I do 1 times 1 is 1. And 4 times 5 is 20. So you get 1/20. If it's too much for you to visualize and do the negative times the negative so you know it's going to be positive and skip over that, then just go slow and do it like I was saying at first. 1 times negative 1 is negative 1. Negative 4 times 5 is negative 20. Your negatives will cancel each other out. So you're left with 1/20. Okay. So all the problems we've done thus far have not reduced in the end. But when they do reduce, you end up, or you have a problem that looks something like this one. So I'm going to just multiply it like we did the others. 5 times 3 gives me 15, and 9 times 10 gives me 90. I know they reduce because they both end in 5 or 0, and so I know 5 at least goes into both of them. So a couple different options we'll talk about in just a minute. Let's reduce first. So I'm going to divide by 5. And maybe some of you have already noticed something else, but we'll talk about that in a minute. And 5 goes into 90 let's see, 5 would go into 9 once, leaving us with 40, so 18. Notice I end up with 3/18, which 3 goes into 18, so I know I can reduce again by 3. Divide both of them by 3. I'm running out of room. So let me go closer so you can see what I'm getting. So you get 1/6. That doesn't really fit. I ran out of room. Hopefully you can tell that's 1/6. Okay, so you get 1/6. But you may have noticed in the beginning right here that 15 would go into both of them. So you might have divided 15 out at the beginning, and then you would have ended up with 1/6 immediately. So either way is great. The whole point is that you end up getting 1/6 is your answer. You have to reduce. You can't just stop here and say 5/9 times 3/10 is 15/90 and call it good. You've got to get that reduced fraction. So this is what I want to talk to you about. I would really recommend this is how you do it. Just multiply. Anytime you see multiply with fractions, multiply numerator, multiply the denominator, and reduce. I'm going to show you now how you can kind of simplify it in the beginning so you don't have to do it in the end, or it just makes your numbers smaller. Sometimes you don't guess the largest number and reduce those enough, and so you still end up having to reduce. So it doesn't always omit the reducing the fraction at the end, but it makes for smaller numbers anyway. It's a great trick, but I find that students usually get confused by it. But if I don't teach it, then they try to, enough students usually vaguely remember the rule, and so then they kind of do it their own way. So I've decided I probably should teach it, and hope that you don't get confused by it, because I used to not teach it because students just would confuse themselves too much. And what it is kind of canceling, and students get like cancel happy. Remember, you can only cancel, and when I'm talking about canceling, excuse me, I'm talking about, I'm going to go up here as a side note. Like if I have 7/7 times 3, let's do it like our prime factorizations like we were doing the other day, times 2. So I'm going to put it like that. These 7s would cancel each other out. Because I have all multiplication, I can do that. Oh, sorry, you couldn't see that. You have all multiplication, so the 7s can cancel each other out and leave you with whatever you have. So 3 up in the numerator and 10 in the denominator. Okay, so that's what we're going to do with these fractions. But remember, if you have it upstairs, it has to cancel with downstairs. So basically what we have here, if we stretch it out, I'm going to go this direction and stretch it out. So I'm going to write 5 times 3. So if I was multiplying the numerators and multiplying the denominators, 9 times 10. So if I were to write the prime factorization of these two are prime, but 9 would break down to 3 times 3, and 10 would be 2 times 5. That's essentially where I'm going with this, is I'm looking for a number down below that will cancel with one up top. And I can't cancel down below. So like I can't say, oh, this is 3 times 3. Oh, the 3's cancel each other out down below, right? Because I'm staying down below. What we're trying to make is a 1, and the way to make one whole is to have 1 in the numerator and 1 in the denominator. So I can say there's a 3 up here that will cancel with part of a 3 down here. So make that 3. There's a 5 in here, so if I divide 5 out, that makes that 2, and I'm going to cancel with the 5 that's up there. Okay, if that confuses you, really don't try to understand this part of it. Okay, you don't need to do it. So in the end, you end up with, there's nothing left up here, so we have to have a 1 to hold the spot. I'm going to erase my little arrow and move it over here. Sorry, my arrow was looking really bad. So I have to have a 1 to hold the spot up here. And down below I'm left with a 3 that I haven't crossed out times a 2. 3 times 2 is 6. So there's our reduced fraction already. So essentially, if we go back to the original problem, you'll get to the point where you're not going to write it out like this in prime factorization. You'll get to the point where you just are like, oh, well, I have a 5 upstairs, and I can divide 5 out of this. So I'm going to cancel 5 out of that and make it 2. Oh, I've got a 3 up here. I can divide 3 out of that and make that 3. So then multiply straight across, nothing upstairs, but you have to have something hold the numerator upstairs. We have to have a number upstairs. So we put a 1, and 3 times 2 is 6. And if this reduced more, then we would have to reduce, because sometimes you don't catch all of the numbers and divide them all out. So you aren't necessarily always done, but if we end up with a 1 in the numerator or denominator, we know it's reduced as far as it can go anyway. So okay, so that's really all the time I'm going to spend on reducing like that. Sorry, my throat is dry. Again, if you understand it, that's great. Just remember, the only time this applies is when we have multiplication. If you don't see multiplication, or you don't know that it's multiplication, remember it could be written in parentheses. Our problem could have been like this. So 5/9 times 3/10. And because there's not a sign in between here, I know it's multiplication right here. That's the only time we can do this upstairs, downstairs, cancel stuff. Okay? Don't do it when we have subtraction and addition. You can't even do it in division initially until you switch. And when we get there, you'll see why. But we switch division to multiplication, and then you can do it after that. But okay, so that is that for that part. Okay, let's move on to what do you do if you have mixed numbers? How do you multiply them? So I'm going to write 3 1/3 times 1 4/5. What I would always tell you, anytime you have a mixed number, it's easiest to change it to improper every time. If you are a visual person, when we get to addition and subtraction, it's not as hard to leave it as a mixed number, but I really recommend, if you're not sure, just change them to improper and then work with them that way. But especially with multiplication, so much easier and really the only way to do it. Okay? So let's change to mixed number, or to improper fraction. If you remember, you start with the whole, multiply it by the denominator, and throw it up, add it to the top. So 3 times 3 is 9, added to 1 is 10, and then we keep the denominator. 1 times 5 is 5, plus 4 is 9. Keep the denominator, and now it's a problem just like we've been doing. So you multiply the numerators and multiply the denominators. 90 over 15. Okay, this is pretty much just like that one problem we had before. So hopefully you remember 15 goes into 90. Divided by 15 is 6, I happen to know, and 15 divided by 15 is 1. You don't need to leave it like this, because we usually don't write 6 over 1. We would write it as just 6. It's just when the numerator is 1 that we have to hold that spot. Because 1/6 is very different than 6 wholes. Okay. So, again, if you have the mixed number, you change it to improper and then multiply straight across, just like the others. That's it for that, and then make sure you reduce your answer in the end. The book will ask you to write your answer as a mixed number once you've multiplied it. I don't really care if you do or not. If you want to leave it as improper, in this case it ends up being a whole number, so I would probably prefer the 6, not 6/1. But hopefully you're comfortable enough knowing how to convert from improper to mixed and mixed to improper that if you ever needed to switch from one to the other, you would know how to do it, and so it wouldn't be that big of a deal if you had one and needed to switch to the other one. But I'm fine with you not, if you wouldn't care to. What do we do if the problem we get is we're going to do 12 times 2/5? It looks different, but it's no different than what we've been doing. Multiplication. I've got a fraction involved, so that's why it's in the fraction, multiplying fraction section. And I can make any whole number a fraction. It's just over 1. We just don't write it. So I'm going to rewrite this. I'll write it here. I'm going to rewrite it so they both are the same size, just because then it's more pleasing to the eye. So same thing, 12/1, 12/1, 2/5, 2/5, times. Okay, and so when it's a fraction times a fraction, you just multiply straight across. I get 24/5. Does it reduce? The only thing that goes into 5 is 5, and 5 will not go into 24, so nope, you're done. So there's your answer. If you want to put it in as a mixed number, you can. Remember to change to a mixed number. From improper, you just divide. So we would do 24 divided by 5. And then you divide it. 5 goes into 24. 4 times 5 is 20. Subtract. And now you have your whole number. Go around and pick up your pieces. 4 4/5. So there's our mixed number answer, and there is our improper fraction answer. Okay, so sometimes it will look a little different. Just remember that any whole number by itself can be written over 1. If you had a whole number and a mixed number, say something like 20, I'm going to write it in a different way. I'm going to use the dot this time. Remember that that's still multiplication. Just another way of writing it. So if we have this, same thing, just make them fractions. This one's 20/1. Make this one improper. 3 times 4 is 12. Add it to the top is 15. Over 5 equals 1 times 4 is 4. 20 times 5. Let's use our trick. So I do 2. Ignore the zeros at the ends when you're multiplying or dividing. You can do this too. 2 times 5 is, 2 times 15 is 30. And then write however many zeros I covered up, which was 1. So we end up with 300 equals, or 300 divided by 4, And I happen to know that 4 will go into 300 evenly. So I'm going to divide both of them by 4 because you have to reduce your fraction, remember? Let me go a little closer. Okay, 4 divided by 4 is 1. 4 goes into 375 times. Okay, so we end up with 75 over 1, which is just 75. Okay, so there's that problem. If we have negatives, remember, just treat it the same as any other. For example, if this would have been negative and this would have been negative, I'm still going to do all of this math the same. All I do is, in the end, I go a negative times a negative is a positive. So my answer is the same. If one of them were negative and the other was positive, I still do all the math the same, and then I go a negative times a positive is a negative. So my answer would be negative on that one. Okay, this is no different than when we worked with just the whole numbers when we were learning at the time in the section we called it integers. Integers, remember, are just positive and negative numbers. So when we talked about a negative times a positive is a negative, the rule still applies with our fractions. They're just numbers too. Okay, let's see what else we need to cover in this section. Let's do variables. Okay, now remember, we're multiplying now with variables. So when we're multiplying with variables, this is when the exponents change, because that's what the exponents are. It's talking about the multiplication. And so if we're going to multiply more, it's probably going to change things. So let's do some and see what happens. So we've got x over 6 times 9 over x squared. Okay, you're going to do the same thing. Multiply straight across. Sorry, let me move that up there. If I do x times 9, that's just x times 9, or 9 times x, right? You can switch them, and we typically write the number before the variable. So I wrote it that way. Here I'm doing 6 times x squared. Okay, 6 times x squared. But you're not done because you have to reduce. So I've got the coefficients. I'm going to look at them first. 3 goes into both of those. 3 goes into 9 3 times, and 3 goes into 6 2 times. I've got an x upstairs and 2 downstairs. So 1 will cancel with 1 here, so I'm left with an x downstairs. Or the denominator. Sorry, I don't think you could see what I was writing. I'll let you look at it. So I did 3 divided my 9 and my 6. So 9 divided by 3 gave me 3, and 6 divided by 3 gave me 2. I had 1x upstairs that canceled with 1 downstairs. That was x squared. So it just became an x. So I have that x there in my answer. And that is my final answer. Okay? We'll try another one with a variable that's got a little more going on. I think I'm going to switch back to the blue. I think it's easier to see. Let's try -6. Let me see if you can see. Okay, -6 over 13h times k squared, that is. I'm going to times that by a negative 26h over 9k. Fix my h a little bit. Okay. So first of all, the first thing I always try to notice are your signs. I'm multiplying, so the rule is a negative times a negative is a positive. Here I don't have any other negatives, so that means the overall sign of this fraction is a negative. The overall sign of this fraction is a negative. Okay, negative times a negative, so my answer I know will be positive. So I'm not even going to worry about the signs anymore. So I'm just going to get my numerator and denominator and see what I get. So I have 6 times 26, and I'm going to write it here. If you don't know what it is, like I don't right off the top of my head right now, you just multiply it. 6 times 6 is 36. 2 times 6 is 12, plus 3 is 156. Okay, so I put my 156, and then I move to the variables. There's just an h times no other variables, so I'm just going to put my h. This is one of those problems that if you can reduce, if you understand the upstairs, downstairs reduce stuff, that's helpful to keep your numbers smaller, but again, I'm not going to go over that again. Rather avoid the confusion. Okay, now let's do the denominator. I do my coefficients, 13 times the 9. So I'm going to write that out. 13 times 9. 9 times 3 is 27. 9 times 1 is 9, plus 2 is 11. So I get 117. And then h times k times k times k. So that means I've increased a k basically. There's no other h's, so it's just h, and k times another k makes k times itself 3 times. Okay, so I'm almost there. I just need to reduce. Okay, so I'm going to come a little closer so you can see what I've got. Okay, so variables are really easy. I've got this h up here and an h downstairs. Neither of them have exponents. So it's 1 for 1. They would make one whole. So those are gone. So the variable I'm going to be left with is just k to the third. I've got to reduce this guy. Well, I noticed that 1 plus 5 is 6, plus 6 is 12. 3 will divide 12. Let's try the downstairs. 1 plus 1 is 2, plus 7 is 9, and 3 will divide 9. So I know 3 will go into both of them, so I'm going to start with that and see where that goes. I don't know how many times they'll go into it, so I divide it. 156 divided by 3, 5, 15, subtract, and bring down. 3 goes into 6 2 times. 2 times 3 is 6. Subtract, and I get 52. So I end up with 52 over, now I've got to do 117 divided by 3. 3 goes into 11 3 times. Multiply those and you get 9. Subtract, bring down. I borrowed, I skipped that, just so you know. 3 goes into 27 9 times. 9 times 3 is 27. And you're done. So we end up with 39 here. And don't forget your variable, my k to the third. So I get 52 over 39 k to the third. Okay, you want to check and see if there's anything that will go into both of those. 3 would go into 39 because 3 plus 9 is 12. But 5 plus 2 is 7. So I know 3 won't work, 7 won't work, or not 7, excuse me, 9 won't work. So we just need to see if there is anything else that would work. I believe it is simplified. So we're done. Okay, so that's that for a problem like those. Let's talk about exponents on the outside. I'm trying to speed this up before my battery dies, so we can hopefully get it all in. If not, there might be a part 2 video. Okay, so we've got 2/5 to the 3rd power. Okay, remember this is multiplication, not 3 times this stuff, but it's saying all of this stuff is repeated 3 times. So 2/5, and we're multiplying in between. Times 2/5 times 2/5. Okay? And if you have a fraction times a fraction times a fraction, you're still just multiplying your numerators, multiplying your denominators. So you could do it like this, write it out, expand it out, and do 2 times 2 is 4 times 2 is 8. Okay? And then bottom, 5 times 5 is 25, times another 5 is 125. And there's your answer. Okay, so this 2/5 to the 3rd power, or cubed, is 8 over 125. Now, if you remember, when we have this guy, this exponent on the outside, when we did problems like this before, we said you could just multiply him in, but you don't multiply him by the big numbers, by the base numbers, you multiply him by the exponents. So I can multiply him by each of those exponents. I have to do it to both of them. Notice they didn't have an exponent written, but remember it's implied 1. So technically there's a 1 there. So I wrote the 1. So 3 times 1, or 1 times 3 is 3. And 1 times 3 is 3. So I end up with 2 to the 3rd. That one's kind of big, sorry. 2 to the 3rd over 5 to the 3rd, which is the same thing as we did down here, because it's 2 times 2 times 2, 2 times 2 times 2, 5 times 5 times 5, 5 times 5 times 5. Okay? So either way, you'll end up with 8 over 125. So you can do it either way. Just remember that if it's out here, it's got to go into each piece. So if we have variables, we've got to put it into that as well. So let's do one with a variable. How about trying to decide which one to do. We'll do m to the 3rd over 2p to the 5th power. Okay. So I'm going to multiply this, but remember, because it's an exponent, it can only multiply other exponents. So I'm multiplying it to that 3. What's the exponent of the 2 and the p? They're 1 because they don't have any exponent written. So I have to go to every piece. I can't just distribute that to one exponent and not do it to everybody else, because they'll throw a fit and be sad, right? You have to share with everyone. Variables and numbers are just like people. They'll throw a fit. Okay, so we're multiplying it in because it's right next to that parenthesis, so we're multiplying if you remember the general rule. So my base stays the same, it's still m, but 3 times 5 is 15. 2 stays the same, but 1 times 5 is 5. And p stays the same, but 1 times 5 is 5. Okay? We can figure out what 2 to the 5th is, so we can't stop there. So I'm going to write my m to the 15th power because we can't do anything with that. We don't know what m is. But 2 to the 5th, remember it's 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. And my p to the 5th. I can't change that. So there is our final answer, because I can't cancel any variables. I can't do anything with these exponents because the bases aren't the same, so you can't touch those. So they just stay just like that. Okay? Let's just talk about positives and negatives with those really quick. Do recall, I'm going to start with a basic number. Do you remember when we did this? Okay, the difference here, this one is saying whatever's inside is repeated twice. This one is saying whatever it's most immediately next to, which is the 4, is repeated twice. And this negative is just tacked on to whatever we get. We have to do the exponent first, and then it's a negative of whatever that is. This, the negative is included in being repeated. Okay, the parentheses are including that negative. So this one is negative 4 times negative 4, which is 16. Positive 16. This one is a negative out here. Whoops, let me do my equal sign. A negative out here, but I've got to do my 4 times 4, and then I'm going to tack on that negative. So 4 times 4 is 16, and so that part is 16, and the negative then goes in front. So my answer is a negative 16. Okay, so now that we've remembered that, if we have let's do a negative 2a to the 4th over 3a to the 3rd. Okay, negative, sorry, I'm trying to see if you can see it. All to the 4th power. Okay, so again, this 4, we can go into each of the exponents and multiply it. If you forget, you can just write everything out 4 times. Times a negative 2a to the 4th over 3a to the 3rd times a negative 2a to the 4th, 3a to the 3rd times a negative 2a to the 4th over 3a to the 3rd. Okay, kind of crazy. So maybe you wouldn't want to do it that way. And then you just multiply your numerators and your denominators. But you can do it that way. We're going to multiply it down in. So this is exponent of 1 technically. I'm going to multiply it in. So I get 2 to the 4th. Oh, sorry. I wrote a 4. 2 to the 4th power. 4 times 4. A to the 16th power. 3 to the 4th power. So remember, I'm multiplying the 1 times the 4, not the 3. There's one exponent right there. And 3 times 4, so a to the 12th. Okay, and now I'm going to look at this and the negative. The negative's being repeated, because it's inside the parentheses, 4 times. So if I've got a negative, a negative, a negative, and negative, it's going to end up positive because I have, 4 fingers, not 5. I have 4 negatives, so 2 are going to pair up, and I can't make my other fingers go together. So each set of 2 will pair up and become positive. Okay, so my answer is going to end up being positive, so I'm not worried about signs anymore. Okay, you need to figure out this number. You need to figure out this number. Reduce your fractions. We can reduce our A's. I've got 16 up top, 12 down below. So 12 down below will cancel with 12 up above, leaving you with a to the 4th. Because I had 12 down, 16 upstairs. So if I take those 12 out of both of those and cancel each other out, I'm left with 4 that didn't get canceled upstairs. So a to the 4th. But again, do the math on this part and reduce that fraction as well. Okay, last thing, we need to wrap up this video. It's way long. Okay, we need to talk about area of a triangle. Let me find the one I want to do. Okay, so if we're given a triangle, any kind of triangle they give us, it doesn't matter if it's turned or whatever. When you're finding the area of a triangle, so I'm going to put a little triangle down here so we know we're talking about the area of a triangle as opposed to rectangle or something. The area of a triangle, the formula for that is 1/2 times the base times the height. Okay? So your base and your height, they're going to be two measures of the triangle that are perpendicular to each other. Perpendicular means that they meet at a 90-degree angle. So like a box. So in this triangle, they're going to give us the height like this. So think of it, when you measure the height of somebody, you do it perpendicular to the ground, meaning you stand straight up and down to the ground. Okay, so in this one they tell us that this measurement is 12 feet and this measurement is 7 1/4 feet. And so they have them labeled feet. I'm not too concerned about the labels right now. Okay? But just for sake of discussion, area means that it's going to be square feet, right? 2 dimensions. Okay, so now I just plug these pieces in. This is clearly my base and this is clearly my height, but because it's multiplication, it's not going to matter if you plug it in to one or the other. They're going to give you your 2 pieces of information, and right now we're not mathematically in a position that we're going to have to try to solve other sides. So it's going to be pretty straightforward with these kind of problems for you guys right now. So you're just going to take basically the numbers they're giving you and plug them in for base and height. So you'll end up with 1/2 times a base. So I'm going to go like this. And I'm going to write it as a fraction just so we can skip that step. Times the height. It's 7 1/4. 7 1/4. I'm going to write it as improper so I can skip that step as well. So 7 times 4 is 28, plus 1 is 29. Keep your denominator, so forth. So this was 7 1/4, written as improper. This was my 12, just written as 12 over 1. This 1/2 is from the formula. Okay? Multiply, multiply. So with fractions, you just go straight across. Okay, I'm going to do the bottom because it's easiest. 2 times 1 is 2 times 4 is 8. And then on top, 1 times 12 is 12. And 12 times 29. So we've got to figure that out. I'm going to erase this, guys, so we don't get confused by him. Okay, so 9 times 2, make sure you can see it. 9 times 2 is 18, carry your 1. 2 times 2 is 4, plus 1 is 5. Put a 0. 9 times 1 is 9. And 1 times 2 is 2. Add those together. 8. 9 plus 5 is 14. Carry a 1 and 3. So you get 348. I wish I had you guys here so you could double check my math. So 348, I'm going to erase it so it's not in the way. So 348 is what we got when we multiplied those. Oh, you can see it. So now we need to reduce the fraction. And actually for this one we will want it in a mixed number form, because again it's a story problem and you're not going to tell somebody a measurement by giving them an improper fraction. We just don't do it that way. Okay, let me think really quick. So you'll get 28. 8 won't go into both of these, but 4 would. Yes, 4 would. So I'm going to divide 4 into both of them. And don't stress if you couldn't figure out that it would. Just reduce by 2 each time. I just did the math quickly in my head. So 348, to save time, I'm just going to tell you what it is. It's 87. And then the only thing that goes into 2 is 2. Won't go into 7. So I'm almost done. I'm just going to divide it since it's a story problem, so I get my mixed number. 87 divided by 2. 87 divided by 2. 2 goes into 8 4 times. Multiply, subtract, bring down. 2 goes into 7 3 times. Multiply, subtract, and pick up your pieces 1/2. So the area of this triangle is 43 1/2. Sorry you couldn't see it. 43 1/2 square feet. That's just part of my circle. Okay? So that's how to do the area problems. Sometimes it won't be written or drawn like this. I'll just show you quickly. You might have one that looks like this, and they give you a little picture, something like that. And then they give you this measurement, say that's, we'll say 7, and this piece is 15 or something like that. So it's not always going to be drawn the same direction, but remember the 2 pieces you need will always meet at a right angle. So you've got 15 and 7 is our height on that one. Sometimes it will be, they won't have these dotted lines. It'll just be straightforward because we'll have what's called a right triangle, meaning 2 of the sides form that right angle. So we would need this piece and this piece. So say this piece is 17 and this piece is 29. Okay, so those are our 2 pieces we would plug into our base and our height. And we could figure out the area. Okay? Alright, let's give you the assignment. Okay, so again, this is 5.3. Sorry, that was a longer video, but there is a lot of different situations we had to talk about. So on 5.3, you are doing, let me get it where you can see it and I won't be moving it all over. Okay, you're doing 1 through 59 odd. So again, all the odd problems, 1, 3, 5, 7, 9. And then I want you to do a couple story problems. You're going to do 73 and 76. Let me just double check. Make sure I really want you to do them. Yes, I want you to do them. Okay, so there's your assignment for today. Pretty quick, easy one. Thing that will probably take you the longest is reducing after you've multiplied. So anyway, have fun with it. Bye.